Have you ever wondered how your favorite game remembers your high score? Or how a website greets you by name? Well, the secret behind all of it is something really simple but incredibly powerful: Python variables. So let's dive in and break down exactly how they work.
Yep, that's the fundamental job of a variable. It's basically the program's memory. Whether it's keeping track of your score, holding on to your username for a welcome message, or storing the price of something in your shopping cart, variables are the little containers that hold all that crucial information.
The absolute easiest way to think about a variable is just as a labeled box. That's it. You give the box a name, and then you put something inside: a number, some text, whatever you need. It's a really simple idea, but it's the foundation of everything. A placeholder for data that you're going to want to use and probably change later on.
And you know, this is where Python just shines. In a lot of other programming languages, you have to get really specific and declare what kind of data you're about to store. But with Python, you just say x equals 5, and Python automatically knows, okay, x is holding an integer. It's so clean and lets you get to the fun part faster.
So we have these powerful labeled boxes. But just like you can't just scribble something random on a real box and expect to find it again, there are a few simple rules we need to follow for naming our variables. This just keeps our code clean, organized, and most importantly, working. And honestly, the rules are pretty intuitive. You can use letters, numbers, and underscores, but the name can't start with a number. And this one is super important. Python is case sensitive. So a variable named age with a lowercase a is completely different from age with a capital A. And finally, you just can't use words that Python has already reserved for its own commands, like if or for. Okay, let's make this real. On the left, you've got perfectly good names like age or total underscore score. But look over on the right, you can see the common mistakes. One name is bad because it starts with a number. Class is a no-go because it's a reserved keyword. And username uses a hyphen, which isn't allowed, only underscores. All right, so our boxes have names. Now for the really fun part: putting things inside them. This is where Python has some really neat tricks up its sleeve that make your code super clean and efficient. Here is where Python's flexibility is just awesome. So we assign the number 10 to a variable called x. When we ask Python, hey, what type of data is x holding? It tells us it's an int, for integer. It figured that out all on its own. This is called dynamic typing, and it means you don't have to lock a variable into one single data type forever.
Now check this out. We take that exact same variable, x, and now we assigned it a piece of text. Python doesn't complain, it doesn't throw an error, it just updates. Now x is holding a string. That variable can hold different types of data throughout your program's life, which gives you just incredible flexibility.
Python is also full of these great little shortcuts. Let's say you need to set up a bunch of variables with the same starting value, like setting a few player scores to 100. You don't need 3 separate lines of code. You can just chain them all together like this. 1 line, 3 variables, all set. So clean, so simple.
And it gets even more powerful. You can assign different values to different variables, all in a single super readable line. Right here, in one go, x becomes an integer, y becomes a decimal number, and z becomes a string. This technique makes your code incredibly concise.
Okay, so we've covered what variables do and how to use them. But to really master Python, we got to peek behind the curtain. What is actually happening in the computer's memory? Get ready, because this right here, this is the aha moment.
So, here's the big secret. The variable x isn't the box that's actually holding the number 5. Instead, Python creates an object in memory. That's the actual data itself, and the variable x is just a name tag or a label that points to that object. This is a subtle difference, but it is a game changer for understanding Python.
So, if we take that idea one step further, what happens when we say y equals x? Well, Python doesn't make a whole new copy of the number 5. No way. It's way more efficient than that. It just creates a second label y and sticks it onto the very same object that x is already pointing to. So now you have 2 names referring to one single object. Okay, so what happens if we then change x to something new, like the text geeks? All we've done is peel the x label off and stick it on this new string object. And why? It is completely unaffected. It doesn't even notice. It's still happily pointing to our original number 5, and that's why changing one variable doesn't mysteriously mess with another one.
And really, this one sentence sums it all up perfectly. Python variables are not the containers themselves. They are pointers or references to the data. Once you really get that, so much about how Python behaves just clicks into place.
So why does any of this matter?
Why do we just go down that rabbit hole of labels and references? Well, because understanding this model unlocks some seriously elegant and powerful ways to write your code. Let's look at a fantastic payoff that comes directly from how Python does this. In most programming languages, if you want to swap the values of two variables, it's kind of clumsy. You need a third temporary variable just to hold a value out of the way. But in Python, check this out. It's one line. A comma B equals B comma A. That's it. It's concise, it's perfectly readable, and it works because of that powerful assignment system we just talked about. And there you have it. From a simple labeled box to a powerful system of object references, that's the story of Python variables. You now have the absolute fundamental building blocks for storing and working with information in any program you can possibly imagine. The possibilities are totally endless. So the only question left is, what are you going to build first?